Are we here? Oh, we're here. Hey, it's me. Wait, I gotta get my void up. Who up with their void? I'm really quiet because my roommates are back, and I didn't think they'd be back, and I didn't think there would be people in our house. But there are people in our house. Whoopsies. Didn't mean to stream when people are over. It's kind of embarrassing. Okay. Let me pull this up. Hey everybody, how's it going? There we go. This is, yeah, I don't know how long this is gonna take, because there's actually like in more math. I know, funny, I'm streaming in math, but like, this is more math than I normally do. Wait, determined by directing, okay. Let me not put the name of the class in there. We don't need that. Here we go. Okay, here we go. Yeah, we're just gonna do some centroid stuff. Should be pretty simple. Should be pretty fun. It's pretty much just so what I want to do is figure out a little bit better personal method of doing this, because my professor didn't explain it very well. One second. Here we go. I'm back. Holy shit. What's up? What's up? Damie, I'm here. I know. It's been a while. I'm gonna send you a GIF on Discord of how I am right now, okay? Sure. I don't know what that means, but okay, I have to find. So the one thing is like, I don't really know what these cues are. He was telling us about these cues, and I was like, dude, what the hell? Like, cause I know, like we've done it, like on stream, like when we used to do multivariable, you know, finding like a centroid, right? Like X bar, Y bar. But like Q is something else. And, so what we have to do is like, we have to find the cues for X and Y. But like, I don't really know what that means. I don't remember if he gave us a handout for it either. Okay, it was sent. Let's see. What is this? The guy with the soap. I love how it pauses and then it like... It's great. That's great. That's me being live after I haven't been live for a week. Okay. I need to like figure this out. Let me see if I can get the lecture notes up. Because he actually... So annoying. This is his worst lecture, unfortunately. It was a very bad lecture. Let's see, 19, is that what it is? Yes, okay. So, CG location, X bar and Y bar from reference axes. Yes. Centroid of an area, okay. So we say that Q is a key term in shear stress. So that's the first moment of area. So we say that this is the let me show you guys. This is what he wanted us to understand, and just by reading it, that's about all the information you get. He didn't explain any of this. He didn't prove any of this. So, okay. X bar. So X bar is the distance from the axis, like it's locating the center of gravity, the centroid. right? We know that. That's something we know. It equals the integral of x with respect to w. What's w? Zoomer math, you like find the surface. I'm not gonna say. If what? Asked Ohio how much Riz would he get? I don't. How much Riz would he get? That's math I don't know how to do. What is the wait? Okay, so x bar w weight maybe. What the fuck is gamma? Density? I genuinely don't know what any of this is. Qy of the axis equals... Okay, it's a moment. But it's like moment of like an area. Okay. Maybe. Okay, we need to find Q's. Hey Damie, fun fact. What's the fun fact? There's this thing called Google. I know, but like if I Google some of this stuff, it doesn't give me... How do I put this? It's like my professor, sometimes people use different terms, you know? Like I can't always, I mean this one I would probably be able to find, but let me find Q's. So Qx equals y bar times A. No. No, that's not what it equals. It equals this over the area YDA. Okay, but like what? Like, why would you say an integral of an area like that? Is your function A? That's kind of stupid is the thing. Is the thing. How do I do this? Okay. Well, let's like make the, okay. I know what the answer is supposed to be. We just need to get there. So, it's gonna be our function is y equals mx plus b equals rise h over a x. So y equals h over ax, right, plus 0, because our intercept is 0. So that's the function that we're integrating. And I'm also going to solve for x. X equals a over h y. So we need those. So q of x is going to equal... Well, what's dA? Do I actually have to do this? Y x bar equals a equal what the hell? A equals... This is the worst explained lecture I've ever had on a topic that's literally just easy calculus. I'm not gonna lie, this is not hard calculus either. This is like... Okay, QY... Okay, we have to define dA. We have to define dA in terms... Oh god, why can't they just say... Why can't they just say... dA... Oh my... This is dumb. Okay. We want it all in terms of y. So it's gonna be x dy. Yes. Yes. Can I please say ax? What is the first thing? Phantom? Anum? Fanuel? I don't know what that is. I think I've reached the point where I don't know TikTok words. It's on Twitter. I might know it. I don't care about TikTok is the thing. I'm gonna just say this equals from 0 to a y times x dy. You don't go on TikTok? What is it from? Is it not a TikTok thing? 0 to a y times a over h y dy. What is that? What is chi sonot? What? A over h. I'm a capital who does math. I don't know what to tell you. I live under a rock. Okay, so y, that'll be a over h times 1/3. Times... Oh, the most subbed to person on Twitch? Oh. A cubed. Wait, this is bad, because h doesn't cancel out. Oh no, it's okay, because we're gonna do it over the area. Wait, I have to find the area. A to the 4th over 3h. Maybe? Is that right? Yeah, I think that's right. I think it's okay that we have that. We'll do qy. So qy equals, okay, a, so this will be x dA. So we want this to equal, this is like double integration, kind of. But like not. But I feel like it'd be easier if you did double integration. That's my take. It's just like really complicated for no reason. xy dx equals 0. This is why we solve like for y in terms of x. So it'll be like h over a x squared dx. So then this equals, right, equals h over a times, right, 3, and then this is going to be a cubed equals a squared h over 3. And then find a. So a equals 1/2 base times height. So 1/2, yeah, base times height equals 1/2, or ha over 2. So x bar. Also, the one so annoying thing about my professor is, right, so we're doing x bar, y bar stuff. When you're integrating all this stuff, obviously, like, we're using x and y in terms of, like, this function, right? Because this is our function. We're trying to find the area from here under the function. He kept writing, like, instead of writing x bar, he just would write x sometimes. It was so annoying. I don't know why. I don't know why it was pissing me off so much. I was like, it's so hard to follow because, like, I don't know. Anyway, qy over a, so that'll be a to the 4th times 3x times 2. Uh-oh. I think we goofed because the h's are supposed to cancel out. How did we goof? H's are supposed to cancel, right? Or am I, like, lying? It's certainly not supposed to be this. Certainly not supposed to be that. Q, okay, oh, I froze. What's up with this? Oh, wait, but like if we're integrating the triangle the other way, it shouldn't be any different. What's up? What's up here? Yeah, x equals over hy. Oh no, I thought this was gonna be straightforward. To be fair, I haven't like cleaned this up yet in my notes because he did not explain it very well. But Maybe if I look at the one of the other integrations we did, it might be a little better. I don't think I should be getting... Wait, am I doing this? Should I be getting to the third? My A's should cancel out, I think. Let me look at this. Let me look at the math. Okay. A over... Okay, that's fine. For my QX... QX is like the moment of... the first moment of area, like with respect to the x-axis, so it's going to be the distance that, like the y lever arm distance. Well, it's respective to the y lever arm. Wait, so what the hell? H's should cancel. Well, my A's are definitely not correct either. For QX, the H's should cancel. For QY, the A's should cancel. Well, let's just try Y bar. So QX over A equals... Oh, that's... Oops, this is QX. But this one is the other one. A squared H over 3 times... Okay, this one looks more right. Times 2 over HA. Okay, so that one's right. Right, so this will go this, and this equals... Yeah, 2/3 A. What the f... What is up with... What is up with QX? What the heck? Okay, I'm doing something wrong. Am I substituting x wrong? A over hy? No. So this is y times x dy, if that makes sense. Okay, y squared a over h. Yeah, you get a cubed, huh? But like your a is compound then. Well, what is up with this area? Like it shouldn't do that. I mean, part of it... cancels correctly. This one just does not cancel correctly. If this were to cancel correctly, this should be a to the... It should be a squared. That should be what we got over here. What the... What is up with QY? Huh? Okay, I'm gonna come back to that one. That's strange and unusual. Because, I mean, half of it is right. We know that it's supposed to be a third and a third. But, don't know why. That's so odd. Okay, anyway. Oh, I lost the other problems. The other ones might be... Find the coordinates for the centroid for the area shown below. Okay, this is another integration one. It's good to practice math, everybody. We love doing math. It's been a long time. I'm not gonna lie, it's been a long time since I just had to do a bunch of integrals. But these are like not hard integrals. These are really, really easy integrals. Okay. So if we want to do... Wait, this is like okay. Let me think about this. I'm gonna Google, okay, like QX as a double integral. Because this is like such a double integral problem, right? We have a top and a bottom one. QX statics as a double integral. Well, I mean, Okay. What about dynamics? Like Q. But okay, first moment of area as a double integral. The first moment of the area around the R is defined as the shape blah blah blah. Yeah, double integral y dA. I'm not gonna lie, it's been a long time since I've done double integrals too. It's been like, I mean, almost a year, which is weird, but a little less than a year. Double integral of like z dA. But double integrals are when we have two variables. If I could just see like one person doing a double integral, I feel like I would, doing a double integral for a moment of area, I feel like I would get it, you know? That seems like the most... How do you find the area of a region you know? Like a centroid equation is... dA times x. Okay, yeah. So this is like what I'm used to. Right, you just jump. So your Q is just your x min, x max, dA, x dA. So like when we would do centroids, right? Like with x equals your double integral of like your area, but like you'd multiply that by x. Like you do x dx, right? Or x dA, and then over a. So that's the same. I mean, that's literally the equation that I use. But this part is Q, because apparently that's used for other stuff. Okay, let's think about the best way to do this. We should probably, let's say, find Q's first. No, let's find A first. If I'm gonna be realistic about it, triangle A minus A equals A. The triangle A is 1/2 base times height, so 1/2 9 times 6 minus this, right? Minus... Or we'll do this. Triangle A equals 1/2 6 times 9 equals what? 9 times 3? 27 inches squared. Okay, now we have to do this area. Is going to equal from 0 to 6. X squared equals square root of, or 2 root y. 2y to the 1/2 dy. Can I do that? Wait, that is dumber. Just do x squared over 4 dx. Because that's the I would have to do 0 to 9 otherwise. Okay, I remember some things. Equals 1/4 times, what is this? So we'll do x squared, which is times 1/3, and then 6 squared. Right? Okay. 6 squared is 36. This is equals 36 over 12 equals 3. Is that right? Yeah, that's right. Let me just make, okay. Let me just make sure my integral is right there. This is really embarrassing if I get this easy ass integral wrong. Like, hello. This is why I need to grade more. Grade more, cat boy. From 0 to 6. If it's not right, I'm gonna be... I shouldn't be teaching stuff. Wait, what? Oh, it's x cubed. Oh no. Okay. That was a little slip up. Like 6 cubed. 216. Okay, whoopsies. Oopsies. Ooh. 8 equals 27 minus 18 equals, let's see, that's 17 minus 8, 9. Okay. Now let's find some q's. Okay, so qx is going to equal y dA. Now, if I was doing a double... So here's the thing. Like, the reason why I feel like multivariable would be better here is because we can just, like, do the, do our, like, little two-function thing, right? Where it's like you put the functions in the limits, and, like, that's not very calculus, that's very multivariable. And I feel like that would just be, like, more straightforward, unless that is a calculus thing. Did I forget about that? Like if our limits are... Or do I have to do double integral for that? I might have to do double integral for that. I don't know, maybe this is just like too... We'll keep trying to do it this way, just because I don't know if that's actually gonna... Okay, so we're going in y, so it'll be 0 to 9. It'll be y x dy. And, I mean, well, in this case, it's like, what are we... Because if you go up... Like... What's our x? I guess it's but like it's defined by these two functions. Oh god. Evil mode? Okay, yeah, I actually should be evil mode for this. It's me just like struggling to remember multivariable. Do I even have my multivariable notebook still? I think I might. It's been so fucking long, man. Let me see if I can grab that. This stream should actually be called Damie Struggles with Double Integrals for 2 hours. so dumb. Physics. Linear. Oh, yes. Yes. God. This might be it. I might have found it. Was this my multivariable or is this my linear? Lagrange. Yes, here we go. Oh boy, okay. Yes, okay. Where's double integrals, my beloved? That's potential. I very vaguely remember that. No, I remember it pretty well. Do I remember Lagrange multipliers? No, I don't. Okay. So if you're doing it, you say the limits of y and then the limits of x. So yeah, we can say one of them is going to give the function and one of them is going to give the limit, like, numbers. Okay, god, this is actually maybe one of the more embarrassing things. So if I was trying to find... The only thing I'm wondering is, like, okay, so let's say that's an A, and we'll say this, because this is real. We're going to say this. So if we say y in here, we're going to do y dy dx. Also, we'll integrate with respect to y first, which is good because we want to get rid of the y. So you want to say, okay, if we go up in y, what are we hitting? We're hitting the 2/3. We need to solve, so x equals 2/3 y equals 3/2 x. And then x squared equals 4y. Well, none of that is true. X equals the square root of 4y. 2y 1/2, or y equals x squared over 4. So if we start, we're going to say, for y, our upper limit is 3/2 x, and our lower limit is x squared over 4. And then x, our lower limit is 0, and then we go to 6. Okay. This I vaguely remember. This makes me happier. I feel like this I can use this in like a more fluid way. Okay. If I can remember how to do double integrals. Okay, so we leave the 0 to 6. If we integrate y, we're gonna get 1. Isn't it just 1? Then uh-oh. Oh no. Oh no. How do I do this? Okay. Example 1. I don't even remember it. It's coming back to me. Okay. When we do... Oh, because our dy is gonna be... Wait, because we're integrating it. Oh my god, I'm a dummy. I'm a silly little dummy guy. Okay. Oh my god. Okay, so like... y squared over 2. Y squared over 2. 3x over 2 to x squared over 4 dx. Right, so then we plug this in. I'm gonna keep going down here. Okay, so our top one, so it's gonna be 3x over 2 squared. I'm just gonna do 1/2. We're gonna do like this. 0 to 6, we're gonna bring the 1/2 out of everything. Just for easier life purposes, there we go. So it's gonna be 9x squared over 4 minus x to the 4th over 4 dx. I wonder if this is gonna like give me the right answer. What if it just doesn't? It's like, no. Okay, let's see. If I integrate this, my professor's gonna look at this and he's like, why did you do it this way? And I'm like, dude, you didn't teach us anything. Okay, anyway. Sorry, I'm a hater. Okay, we integrate this. We do 9/4 x cubed over 3 minus 1/4 8 9 x to the 5th over 5 from 0 to 6 equals 1/8 times, I don't know, what is this, 9? Okay, calculator moment. What is that? I can look over there. Let's see, 6, well, it's nice that it's gonna be 0. 6 cubed divided by 3, 72 times 9 equals a big number, and then 6 to the 5th divided by 5. 150. Uh-oh. That's a negative number. Fuck. What did I do wrong? Is that not the upper limit of y? Is that the lower limit of y? Is that? It's in x. X is 0 to that. Double integral calculator. Double integral calculator. If we have y dy, right, it's gonna be y squared over 2. X squared, yeah, minus that. Yeah, I don't, okay. We're going. We're doing it. Okay, so from, what is that? What did I say? X. I just want to like sanity check because I might have just like set it up in a way where it actually is the right answer, but it's like it's just oh god, I can't like select this. X divided by 4. And then no, get rid of the squared there. Very small. And then what is it? 3x over 2 and then 0, 6. It might just be I set it up in a way that's going to give me a negative number. Oh no. Wait, x to the 4th over 32? Huh? Did I square something wrong? So let's see. 9x squared over 8. Well, yeah, that'll be over 4. So over 8, sure. X to the 4th over 32 though? Wait. Oh wait, 4 squared is not 4. It's 16. That might fix it. I pulled out a 4. This one should be 20. 420. Okay, wait. So 6 to the 5th divided by 5 divided by 4. 388. 60 minus 3. What? Wait, 338. 388.3 equals 259.7. Is that what that is? 162 to 162. Divided by 5. Wait. Okay, this divided by 8 now. No, this one. 32.46. Okay. I got it. Everybody. I got it. I'm winning. Let me just like let me do this in a way that's not really dumb. Okay. Okay, we have this. I'm gonna do 1/2. We're going to pull out times 1/4. I'm going to clearly pull that out. Then we'll have 9 times 6 squared over nothing minus 6 to the 4th over 4. Also wrong. 9x squared. No, I don't want to pull out the 4th. God damn it. Okay, it's okay. I just need to warm up. 9x squared over x cubed over 4 times 9 over 4 times x cubed over 3. That's what I wanted to write. Minus 1 over 16 times x to the 5th over 5. That is the better way to do it, and we're going to say 6, and we're going to say 6. And that's going to equal our thing. So, let's see. I'm going to close all this stuff. Close that too, close that too, close that too. Oh god, I have so many things to close. Okay. 9 times 6 cubed. Did I pull out a calculator? I'm going to pull out a calculator. Thank you everyone for coming with me on this this journey into remembering all of the things that I should really remember for my degree. Okay, 9 times 6 cubed divided by 4 divided by 3. And then 6 to the 5th divided by 16 divided by 5. And then this minus this divided by 2. 32.4. We stay winning. Okay, I didn't need to do that many times. This is inches cubed? What is it in? So it's an area times a thing, so inches cubed. Sure. Okay, everybody ready to do QY now. Woo. Okay, let's see how fast I can get it to go. Okay, QY equals A, X, dA. Cool. double integral. We want to do x dx dy. So dx is going to be the first thing, so we'll use our 2/3 y and y to the 1/2. No. 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 Ew. 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 2/3 y. That's better. 2y over 3. It's going to be so great. Oh, wait, no, it's going to square. We're fine. Oh, thank fuck. Okay, and then 0 to 9. Okay, this is going to equal 0 to 9. X 1/2 x squared at these limits. Say 2 root y, it's a little easier to read. 2y over 3 dy. That's going to equal 1/2 times 0 to 9. Alright. We put the top one in, so it'll be 4y squared over 9 minus 4y. Yeah? Yeah, dy. Can I explain SR latch? What is that? I do not even know what that is. Is that like a... Is it a physical latch? Is it like a holdover from when we used to do like gates, you know, like gates and stuff, like logic gates? That's, I do not know. I've never heard that before. This double integration is going easier though. I'm pretty pleased with that. Okay. We need to do the integration part first. So 4 over 9 times y cubed over 3 minus 4 times y squared over 2. Oh, a state machine? I vaguely know a little bit about state machines. Like, or I guess I know the idea of like... I think when I did it, it was like, you have a state and then like you can travel to different states, right? But like to keep track of different things, so you might have like, you know, you might go here to here, or like from here you might go to here. But I never actually did it in a, real way. How does yellow, red, green work in a state tracking machine? Oh, well, so you would like have like a red, you'd have like a yellow, you'd have a green. And so like from red, you have to go to yellow first. And from yellow, you have to go to green. And then from green, you go to red, I think. Like, I mean, visually. That's actually like a pretty, that's an easy enough example that I can do it. I'm not very... This is gonna equal, and I'm gonna put, I'll put the 9 in here. At least they're always from 0. But look at that. Okay, that one didn't even take us that long at all, so. Alright, let's see. 4 times 9 cubed divided by 9 divided by 3. Native Bay? Ooh, I don't know what that is either. That sounds cool though. Uh-oh, I got a negative number. Fuck. It's not good. Oh, what did I do wrong? Where did I go wrong? Let's see. I squared both those. Got that x squared, I got that 1/2, but like it shouldn't be a negative. Wait, maybe it could be a negative. This is the first moment. Oh, it could just straight up be negative. Wait a second. It's because moments can be negative. We don't gaff if a moment is negative. It's just a directional thing. Let me pull up my double integral calculator again. Logistic algorithms. Let me see. Logistic algorithms. Like regression? Like machine learning stuff? I do know a little bit about that. Just a skosh. I have to change one thing on my memo document. Guys, my memo is so bad. Oh my god. Getting rid of this. It's going to memo hell. So move the background procedure to the next page. Oh my god, these people are so dumb. Sorry. They're not dumb. I love my group so much, guys. What is K nearest neighbor? Ugh, machine learning is so complicated. But like, I think, okay. Because I didn't really study, like, okay, in a weird way. First off, when I studied AI stuff, like ML stuff, I studied it at a time before it was now. I'm terrible at math completely, but this is utterly fascinating. You like me just messing up stuff. Though this is like not even the interesting part of statics. I'm so sorry. This is just plugging in numbers. But so I studied AI and machine learning stuff like a couple years ago, and so I was really interested in more like mathematical techniques that weren't really that good. But like now we've come a long way, so I don't even know if like these explanations have been updated because I studied it like 5 years ago. Oh my god, that's a long time. But yeah, it was like not super long, but long enough for the place to change. But yeah, like K nearest neighbor is about like, I think because it's image classification, right? So like you'll look at, I mean sometimes like for ML stuff, you might have a bunch of different, like you'll have a bunch of different pixels, right? And why do we want to reduce the third dimension back into 2D when I don't know that much. I was gonna say like you're looking at the difference between stuff, and you're traveling along things when clustering. Yeah, I never took it as a math. I'm self-taught, so I was like very much in the theoretical like conceptual space. Anyway, let me just plug this double integral in real quick to make sure I like didn't fuck everything up horribly. Okay, dy dx first. No? Yes. No, I did it the right way before. Oh no, gamers, wait. Did I flip the bounds of integration for this one? Oh no, wait, I might have been kidding. Was it saying dy? Was it saying when I reload this? Oh no. Oh wait, no. It probably was fine, because it didn't like yell at me for it. A decision tree? Oh, I feel like isn't a decision tree just like you make well, I don't know, in a program again, it's like the syntax of it. I don't know the syntax of it. Let me plug this in first. So we're doing this one. So that's x, and this one is 2 square root of y. Random forest. Oh, I vaguely remember that. I vaguely remember that. I love like thinking about programming sometimes because I just straight up do not have to think about programming anymore, which is like kind of depressing because I like it. It's really very cool. But yeah, I haven't thought about that in a long time. -9. Wait, a negative number. Guys, wait. It might not be Jover. Wait, okay. 108 minus 162. -54 divided by 2. Uh-oh. I got -27. That's not the same thing. Oh, God damn it. Oh no. Okay. Did I get my other shit right? Wait, let me see. X dx. 2 square root y, 2y over 3, 4y. Oh wait, I can check there. Wait, 2y. Oh, wait. What? Wait, what? Wait a second. Wait. Wait a second, this is an integral. Wait a second. Did I put it outside the integral? I put it outside the integral, I think. Can it solve the actual integral? Yeah, negative 27. Okay, if it solves the actual integral, it's negative 27. Okay. That makes more sense. Can it be negative? Great question. I think it can, because if we're solving for x bar and y bar, like x bar and y bar can be negative, and our area is not going to be negative. So that's the only way it can be negative, is if our moment is negative. How do you explain the k-means cluster? Okay, I've never done Python. I will say I've never done Python. Python is my one thing that I have not done. This one is like a weird number. This one, nice number. Okay, let's see. So find x bar, y bar. Cool, we just divide two numbers. Okay, I will say this makes me feel a lot better than what we did on the last problem. So, cool. Okay, x bar equals qy over a. So that'll be our qy we just calculated. That's our negative 27 over 9 inches cubed will cancel out. Or sorry, inches squared will cancel with inches cubed, and we'll get inches. So that'll be negative 3. And then our y bar equals qx over a. Look at that, we stay winning. Okay, 32 more just over 9. Let's see. What do we get? 32.4 divided by 9. 3.6. Alright, so that means our x is off the screen. That seems wrong, actually. Fuck. Why is it negative? It should be like here. It should be like on the centroid. It should probably be like here. Okay, we're gonna come back to that one. We're gonna come back to that one. Oh wait. Oh no. I should have thought about this. Your rightmost limit is it's the opposite way around. Your rightmost, okay, it's just flipped. I just flipped it. It's like not an issue. It's 2 root y here and 3y over 2 here, which means that everything will be flipped. That's like maybe the best problem I could have though. So it's positive 27. There we go. Yeah, so 3 inches, like literally directly in the middle. Who could have guessed? And then 3.6, which is like down here, which makes sense. Okay, we stay winning. Never mind, that's correct. Right, I hope it's correct. I can't tell if it's correct, but maybe there's selected answers. Let's see. And then I'm gonna look at the selected answer and it's gonna be wrong. I know it already. The gods of statics are laughing at me. This first moment stuff, without actually saying a as a an area integral, is like, look, they show it as a double integral right after, and I'm like, just explain it as a double integral. We've all taken multivariable. Look at this. This, what the fuck? This? Yeah. It's so much better. Okay. I don't know what an XL? Bro. Miss me with that. Okay. Is there selected answers for homework 10? Homework 10 select answers, baby. It's gonna be wrong, but let's check it anyway. Ooh, y bar equals 3.6 inches? Ooh. We did it! Y bar equals 3.6 inches! Let's go, baby! Oh, yes, okay, yes, we stay winning. Okay. I mean, did that take a very long time to do? Sure, whatever. Okay, it's a centroid of a composite area now. That's easier, it's way easier. I mean, centroids of composite areas are just like, they're easier. Okay, we need to do a lot of math still. Okay. We wanna like okay. This is gonna be 1. This is gonna be 2. So we have two centroids. Basically, our thing is that if we add up all the x bars that's going to equal our big X bar. And if we add up all the Y bars, that's going to equal our big Y bar. So what we can do is we can find the different X bars, Y bars, and then we can just add them up. I think. I say I think because I can't remember if we do that with the Q's or with the X bars, or sometimes we have to do it with Q's if we don't know the X bars. Like, for example, for this square, we'll do this. We'll say square dash 2. We can say we know that if this is 20, its X bar is going to be -10. This is right in the middle there, and then its Y bar is going to be +8 inches. Just from its dimensions. But a semicircle is a little different. So malloc works by using divide and conquer algorithm when requesting memory in C. Never programmed in C. I almost took C, but I'm taking MATLAB instead next quarter. So, we can do MATLAB streams. That might be fun. It's asynchronous. It's probably gonna be really easy though. I mean, like, coding is coding. I've done C#. Coding is coding now. Let's see. We might do that after. Wait, how many problems are there? 4, 5, 6. Okay. These are just composite areas though, so we're chilling. Let me snatch. There's a paper that he had. Here we go. Yeah, I think. Yeah, we can't just. Unfortunately, we can't just do this, can we? The centroid of the whole shapes. How well do I handle horror? Depends on the horror. The horror. I don't really like gore. I get squicked out. But something like Phasmo. I was gonna play with my roommate. I would probably be fine, but it's like initial the initial equals 1 second X initial A initial AI. Okay. I feel like the initial time I would play it would be really scary. Alright, let's find some areas. Lethal Company. Ooh. I'm just not very much of a gamer. I mean, because my break is, I have a week break coming up next week, so I'll be able to stream some stuff that's not school stuff then. But then, winter break, I'll also probably be streaming some stuff. Okay, so for one, it's gonna be pi r squared, everybody's favorite. It's gonna be pi times, what, 38 squared? Ew, it's a huge number. 1444. For 2, that's gonna be 16 times 20. 320. And so, A total equals 144 I minus 320. I don't know, I put inches squared there. I didn't put it anywhere else. This times pi, baby. Actually, we'll also probably do a lot of data analysis stuff over break. I'll stream it. Ugh, that's such a gross area. Anyway. We'll keep some sig figs, but we don't really need that many sig figs. 0.5 squared. I think doing I kind of wish I had taken the engineering statistics class I'm taking like earlier, but I feel like this is also a very good time. I think fall quarter of the second year is a good time to take it because it really gets you just thinking about measurements. So like when I'm doing this kind of stuff, it's like, I know I don't need decimal places here. But it, like, I get how much I don't need it. Like, now it's been put into perspective. We'll do Q's. Wait, do I have to do Q for each piece? There's no way. No, I don't have to do it. X bars and X bars. XI, YI. And I'm always gonna, yell at me if I don't do this, I'm always gonna put the bars over them if I'm talking about the bars. So for 1, I don't want to do that one yet. We're going to do 2. Xi equals, we already did that, so X, wait a second. No, it's okay. Yeah, X bar is actually X bar. -10. Yi equals 8 inches. I was worried about those Q's. And then for 1, we have to look this up in a table. Where's my table at? I don't know. General information, syllabus, mechanics math? What the heck? No. What? No. That's not what I need. Where would he put this? Oh, maybe he just put it in the lecture? Oh, he did. Okay, cool. I'll zoom into this. X bar equals 4r over 3 pi. Wait, that's quarter circular area. Oh, X bar equals 0. Yeah, that makes sense. And then Y bar equals 4r over 3 pi. Equals, alright, so that's, I'll just do that. Sixteen point 16.1. Just cool. So then we just have to like multiply everything together. So X bar equals -10 times 320 plus 0 over 4 is 26.5. Then Y bar equals 8 times 320 plus 16.1 times whatever this number was over this number. Hell yeah. But did my music just stop? I thought it just paused. I thought it was changing the song. It was pinging me. Oh, okay. I have a chem midterm tomorrow. I could be studying for that. Doing statics instead. Wait, is X bar really negative? That seems strange. Wouldn't it make more sense for X bar to be on the other side? Yes, it does, because this is a negative area. We have to put a negative in there. So this is a negative. There we go. Important. 10 times 320. This divided by this. Well, that also seems kind of wrong. But I mean, I guess kind of realistically... I don't like that. Let me see the other one. 8 times 320 Oh, that'll be a negative number. 144 pi times 16.1 minus 8 times 320. This divided by that number that we have, that's 16. Okay, that makes a little more sense. 16.7 inches. That's like here. Which, like, I can vibe with. Or no, it's not that much higher up. It's like right there. But then the what? The X? I mean, I guess there's like a lot of mass on the right. It just seems really weird that it's only up down off by like a little bit, and we cut away a lot of material. It'd be what, 10 times 320 divided by 4261. Well, numbers don't lie. 0.5. 0.76 inches. Huh. Let's check that select answer, shall we? 47, y bar equals 47 millimeters? Oh, there's no selected answer for this one. I was like, yeah, how do we get to millimeters from here? Oh, that's, that would be, scary. Alright. How long are we doing? Okay, we're chilling. I don't want to work on the memo. It'd be fun to work on the memo with you guys. Okay. But I should get this done. And I also don't really need to get that memo done right now. I should... If anything, I should do chem if I'm not doing statics. But... Such is the engineer's struggle. Okay. We have some shapes and sizes. I'm just gonna split it here. This will be 1. This will be 2. And this will be 3. I like doing areas first. I think that's fun. Areas. So we'll say for 1, that's 70 times 70. It's a positive area. For 2, this is going to be 1/2 pi r squared. Oh ho ho! I did do over 2. That might be why the area is so off. Whoopsies! I'm just gonna circle it really big in blue and pretend that I did that already. Okay, well maybe I shouldn't circle it right there. I'm gonna circle this right here. Do this. Lol. Whoops. Oh. The 2. Equals. What's our radius? 35. 35 divided by 2. Nope. Here. 35 squared times pi. No, that's not what I clicked. Pi divided by 2. 1942. 24. I'm just gonna truncate to round numbers. We got 4 sig figs. And then 3, this is our negative area. This one is pi r squared. Negative 14 squared pi. 615. 616 actually. Okay, I closed every window at the same time. That's not useful. Thank you, Damie. There we go. Just closed everything. Is it 616 or 617? 616. Cool, so we got those, and the total is going to be 49. 100 plus 1924 minus 616. Look at how nice it is when you don't have decimals. 6208. Cool. Okay, now we gotta do x bars, y bars. So for 1, our x sub I is going to be 0. Right, and our y sub I is going to equal 35. For 2, our x sub I is going to equal 0. Our y sub I is going to equal, what was it, 4r over 3 pi? No. 4 pi over 3r? 4r over 3 pi. Which equals 4r, so 4 times 5. 35. 14. 8. 15. These are all in millimeters. And then for 3, our xi, again, is going to equal 0. Okay, that's nice. Our xi is just going to equal 0. I mean, it's symmetrical. I didn't even really need to calculate that. I probably shouldn't have done that, but what's you going to do? And then for a circle, it's a circle, it's also just symmetrical. Y I bar equals 0. Well, no, it doesn't equal 0. It equals the placement of the circle, which is 70. Whoops. Alright. So an x bar, big X bar, equals, okay. Equals 0. I don't need to write anything more for that. Big Y bar, however, equals 35 times 4900 plus 15 times 921 minus 70 times 616 all over 6208. Okay, I'm feeling pretty confident about this one. 4900 15 times 1924 70, oops, it's clear, 70 times 666. This, plus this, minus this, over 620. Oops. 25, that's wrong. That's wrong. Or at least from, we know it was 47. It shouldn't be that much off, even if I don't sig fig it up. What am I doing? What am I doing? Y bar. Yeah, 5.4 Y bar. I don't think I added... Yeah, it's 15 plus 70. So this is 85. Because it's from the... It's not just from the... We have to do 85 times... this plus... Oops. Plus... What? Where are we at? This... minus... this number divided by 6 by 2. 47. Awesome. So swag. Swag and cool, actually. This one. Oh, the two. We'll do it later. We'll fix it. We'll fix it later. We'll fix it in post. We'll fix it in post. This isn't due tonight. Like, you think I'm doing my statics homework the day it's due, like I do every other time? We're being a good capital this time. We're getting it done. Alright, centroid of the composite area. Well, now this guy is a little funky silly. Okay, never mind, it's actually very easy. I looked at it and I was like, I do like this shape though. Okay, we're gonna say this is 1. This is 2. This is 3. And this is 4. The areas first. 1. 30 by 30. 2 is gonna be, I want to call this one 4 actually. This one 3. 2 is pi r squared over 2. Or pi, let me like not put r in there. What is the r? 30 squared over 2. Squared. 3 is going to be 1/2 base times height, so 1/2. Okay, base height is 30 squared over 2. Goes 450, I think. And then 4, our negative area is pi r squared, which is pi 15 squared. Negative, negative. 706. 707. Cool, so then total. I feel like this is a very, like, I mean, the only thing I would say is maybe if I put the Q, like, maybe we try putting the Q's on the right over here. Might be a little easier to see. 900 plus 400. 1413 minus 707. 2007. I always like it when numbers come out to be a year that I lived in. Kind of fun. Okay, we're gonna do the x bar 1, x bar, y bar over here. Or 1. So xi equals, alright, the center of this, it's gonna be over 15 up 15. For 2, it's gonna be okay, so in this case our y bar is gonna be 0 and our x bar is gonna be the 4r over 3 pi. This is confusing. I don't like that. And our radius is what, 30? 4 times 10 divided by pi. 12 or 13. And yi equals 0. I don't know how useful this is going to be, but we're going to try this way. Okay, triangle is a third and a third. So 10 and 10. In this case, it's going to be positive 10, negative, wait, so x 10 yi yi equals negative 10, I think. It's me saying millimeters. Then scribble is millimeters. Yeah, negative 10. And then the circle. Oh, well, the circle is 0. Cool. So now we do equals, alright, so 15 times 900 plus 13. 13 times 14. 14 plus 10. I don't know. I feel like this is a little cramped. Is my only take? Over 2 and then y Yeah, it feels a little visually like maybe if I made one column just for the X bars and one column just for the Y bars, I don't know. Oh, we're getting into territory that feels a little squish. Okay, 15 times 900 plus 0. So minus 10. We got so far. We got so far this stream. Oh my god, I'm so sorry. So let me just do these numbers. This reminds me of like calculating molar masses where like I want to do it all in one line, but then I'm like worried that it's not gonna like actually work. Okay, this one is 18 millimeters. Let's see, does that make sense? Like around here? Okay, yeah, I can see that. And then this one over here. Four point 4.5. I really can't. 4.5? Yeah, that makes sense. I mean, it is horribly, horribly truncated. 4.38? Okay. Yes. I mean, maybe I'll like 4.48 millimeters. Sorry. Precision. Here, wait, I'm drawing a little funny face. What's a little like the person who's like, sorry, war crimes. We'll do this. There we go. If I was a grader, I would have a good day seeing that. I should also probably like, you know, maybe like box my answers. Cool. I feel like that's good. I mean, okay, I typed God, not God. That's good. There we go. One more, and then we could do some chem. We could do some memo stuff. I don't know. I feel like chem is probably the better choice, smarter choice, but ooh, this is like, ooh, wait, this is exciting. Do I even know how to do this one? I don't think so. Wait, let me just check if, like, because tomorrow we might talk about how to do this specific problem. This is, wait, MOI? What the fuck is MOI? AMOI? What? Please tell me it's a load distribution. Oh, it's not. Uh-oh, he doesn't intend to tell us about load distribution, huh? He just wants us to know that, huh? Yep, that's what that is looking like. Okay, King. I think he said, like, you have to... I think we just have to take like, find the centroid and then apply the load to the centroid. I think. I think. Potentially. Let's go for it. Let's just go for it. Find an equivalent single load W and corresponding X location to be equivalent to the line load. This is a very mechanics and material problem. Oh my god, wait. I didn't tell you guys. I did my registration. I have a 7 a.m. to 9 a.m. mechanics and materials class. Welcome to my awesome life. I hate everything. I'm gonna be so EP. I'm gonna be so EP Monday and Wednesdays, but it's fine. At least I got into it. I needed to take it's a prereq for a lot of stuff for me, so like I need to take it. Okay, so I don't know why they give us like 3 feet and 4 feet. Like, what's up with that? Oh. What the hell? It's like not a I'm gonna ask him about this one in class. We're not gonna do that one. Let's just fix the 2. Start by fixing the 2. 2, and so pi... Oh, get out of here. I'm just gonna say that, and then we're gonna do 1, 4, 4, 4, divided by 2, and times pi. I like doing that better. Times pi 2. Okay, so 2,268.2. Fuck it. We're doing the roundings. Alright. That one's fine. That one can stay. Get out of here. This is... Oh god, why did I do that? There we go. So 2268 minus 320 is 1948. 1948 inches squared. I think everything should like roughly be the same. 1948. 1948. But yeah. We should get probably a higher y, well, definitely a higher y-axis. Okay, so 10 times 320 divided by 1948. 1.6. Still not great. I don't know why that's weird. 1.64. I don't like that. I'm just gonna mark this one. We're gonna mark this one and come back to it. I'm trying to do this with... Well, okay, see, here's the thing. It's like, if I do this double integration... I mean, it could be kind of goofy if I did it with double integration. Should I just do it with double integration as like a joke? Okay, wait, which one worked? QY worked, right? Let's do QX as a joke. Let's do it with double integration. Let's do it with double integration. Just for the meme. Okay, so that means we want to do y dy dx. So our dy, okay. When we go up in the y, what do we hit? We hit h over a x. hx over a, and when we go down, we just hit 0. And then for x, we go 0 to a. Is this overkill? Yes. Yes. So this is 1/2 y squared, right? So I don't even really need to do this. It will be hx over a. I feel like doing that is probably better. No, we'll do, yeah. 1/2, 0 to a. Alright, let me pull out all the variables, right? So h squared over 2a squared from 0 to a, x squared. What am I doing? I'm double integrating to find the area of a triangle. You know, the most normal method of finding the area of a triangle. Double integration. h squared over 2a squared times, and then we'll do, right, so that's x cubed. It's gonna be a cubed over 3. Okay, but here's the thing, is that just worked. Equals h squared over 6a. And if we like put this in here, h squared over 6a times, right, h a. Wait, no, it didn't work either. Okay, this part worked. The 3 worked. And the H cancels. Wait, no, I got rid of the one that was good. Oh no. Come back. Okay, let me move this over here. This one is the one that's over there. And this one is the one that's over here. Wait, but that didn't work either. Why is this not working? What's going on? Why is the math not mathing, so to speak? What the heck is going on? Okay. Because like h squared over 6a times, we flip it, 2 over ha. H. Let me look really closely at it. If I look really closely at it, maybe my problems will go away. A cubed over 3. These are with an a. Does your a go away? What is up? Why does the a not cancel out? It should cancel out. It's so close to canceling. If this a was here, it was like 1 over. Wait. Wait, the a is on the top. If this a was where I wrote it, then it would work out. Oh, that's crazy. Oh no, oh god, oh my god. It's almost like it works out because a is where it's supposed to be. Oh my god, oh my god. Okay, wait. It's supposed to be 2/3. No, it's not supposed to be 2. Wait, it is. We're chilling. It's h over 3. Yeah, because it's here. Oh my god, Jesus Christ. I can't believe I double integrated to find that. Don't do that. Actually, do that. Who cares? Do whatever you want forever. It works. This works for every single question they could possibly ask me, so I might as well do it that way. It's not confusing at all. Well, okay, it's not confusing at all might be an understatement, but it gave me the correct answer. This one is worrying still. Why is this? This one is strange and unusual. Who is questioning you these things? The questions or the I'm thinking about if it's gonna be easy for my professor to understand. And if other people reading it would have an easy time understanding it. Oh, I'm still emo. I think I've stopped being emo after I figured out the double angle, or not the double angle, the double integral. And this one is, well, this one is just a funny little silly little guy that I should probably let me look in the lecture notes real quick. He said it so briefly. He was like, "Oh yeah, by the way, you can do this with the thing, and then if you replace it, you could put it on the centroid." I'm like, "Okay, sure, go off. I get it." For one that was a load that looks like this, but maybe it's just the area under this. Water time? Oh god, no. I have some water. Fuck you. Your secret attack won't work. Okay. Thank you. Thank you for the hydrate. I have my water. Let's go. Water W. I love hydration. That's great. Thanks. If I can hear you just saying the word water outside right now. You're so mature. Oh, I don't want to do chem. I should probably do chem though. We could do boring memo work. Oh, Engineering. Sorry, Bob. I love my roommates. They're great people. You know what? Fuck it. Fuck it, we ball. I'm gonna work on this. Okay, wait. Am I gonna dox myself by putting my entire name? I mean, yes, I am. Let's fix that. Let me just crop this a lot. Like a lot, and crop this. I probably shouldn't do it on this. Do it on a different one. That's okay. We could do that, but let's not do that. Let's do memo. Okay, let me change the capture. There you go. Okay, that's actually, I can't believe I cropped it already and it was still that much. Okay. Oh, because it's cropped on this side. Oh. Whatever. I don't know. You guys remember data analysis? I have to work with that. I have to work with this. I need to take all of this and turn it into something useful. Because it shouldn't be here, and it also shouldn't be like this. This is a side quest. This is a side quest, by the way. This isn't math. Well, like, it's kind of math in a way. There's some math. Oh, we could do... Wait, let's see the attachments. Oh my Jesus Christ. What the fuck? Why does it look like this? Oh no. Oh no. My real reaction. Oh my god. Who decided that this was a good thing? Oh, what kind of scientific problems am I solving? Well, so for this, this is a memo about the time constant calculation for a thermocouple. So like response time. So you can see, this is a better graph to see it. It also doesn't look like shit right now. So this is, we heated it up to a certain temperature, and we pulled it out into still air, which was a lot cooler than the heated temperature we had heated it to. And you can see this one, so this is like a sequential graph, so it's temperature versus time. So as you can see, this one, this thermocouple, its temperature decreased very, very rapidly, but this one decreased very, very slowly. The issue is the company who wanted to use these thermocouples, this one is the one that they're currently using. I think that's correct. Yeah, that is correct. I just wanted to make sure our labels were correct. But yeah, the 30 gauge thermocouple, it breaks very easily because it's very sensitive. It's like a very thin wire, and so they're trying to figure out. We have to do statistical analysis to figure out if the 20 gauge thermocouple is going to meet their response time that they set, like the limit for it. So I was going to check on our. This looks so bad. We'll have to fix that. Oh god. Someone's typing on the document. Okay, time constant. Let's see. The following data points were extracted from the data seen in Figure 2. Figure 2 is the first trial. That's alright. Starting temperature. We should mention that the starting temperatures were average. Mention the starting temps were averaged. What scientific experiment would I do if money was no object? Well, so I'm not really into research as much, but in terms of stuff I would build if money was no object, well, I feel like I'd like to build some sort of mech, like some exoskeleton type beat, with lots of really cool servos and electronics. But in terms of experiments, I think I'd probably work with fluids. I really enjoy like fluid dynamic stuff. I'm so normal about it. Yeah. That's my answer. Okay, I probably shouldn't comment that. Probably shouldn't comment that. I have the comments here from me. Okay, so for the 20 gauge thermocouple, the first time constant occurs within this, we probably should say Y, but like go off, I guess. What's the difference between a solid and a fluid and a gas if it's all the same stuff? Well, that's a great question because it's chemistry. That's exactly what I'm doing in my chemistry class. It's really just about the how locked in the molecules are, right? So it's just the average like temperature of the molecules is like their average kinetic energy, right? So in a gas, gases usually exist at like high heat or high pressure, and their molecules are all really easily moving around, same as in a fluid, right? But it's not like a fluid can just fly up and away, and then in a solid everything's like kind of locked in. That's the little chemistry answer. Process for finding the time constant will be the same. It's okay. I can understand it, but it's because I know how to do it. My calculations are pretty decent, except I didn't do any uncertainty. Okay, this is better. Estimate for the true time constant. Kind of right. Estimate for any time constant, for a time constant of any thermocouple from the population. 30 gauge population mean, sample mean. Yep, I like that. I like that. Okay, 20 gauge population. Cool. Okay, that's better uncertainties. Because our uncertainties were very bad, is the thing. They were very... Wait. Uh-oh. This one is very bad. When your uncertainty is larger than your nominal value. Oh yeah, it's 3 seconds. Plus or minus 5 seconds. It can be -2 seconds. It's so bad. This one is so bad too. What the... Oh god. Wait, what is happening? Why? Okay. This is so bad. Oh my god. This is the one that I wrote. For our time constant in terms of radius. Okay. That's fine. That's fine. I like that. That's good. 4. But the other stuff, God. This graph is actually making me piss my pants. This is not good to look at. I'm sorry, guys. We gotta fix that. Okay. We have to fix this. So we did not set a reference junction for the thermocouples. That's a very strange thing to say. The thermocouples produce a voltage. Sure, when the temperature at the reference junction is different than the temperature at the measurement junction, which is then interpreted to a value of temperature. It's true. If the reference junction stays at a consistent temperature, all temperatures read will be consistent with each other. True. For the data that we need to determine the time constant, the real temperatures we measure are not important. Not true. And the change in temperature is the important part. Well, okay, the change in temperature is an important part, but the temperatures we measure still matter. Since the real value of the temperature is not necessary for our conclusions, it is setting and trying to... Okay, that is not... Okay. What I think he's trying to say is that we don't use like an ice bath to reference it. But the reason we don't use an ice bath to reference it is because we're calculating this based off of like the TC reader. So let's say this. Let's say we decided to use the standard reference temperature setup included in the thermocouple reader for this procedure, because we were not interested in changing the manufacturer tables for thermocouple voltage to temperature. Yeah, because we're not interested in changing in calibrating the thermocouple is probably a better way to say it. In calibrating the thermocouple. Response time is independent of the accuracy of the I don't like saying accuracy anymore. Accuracy is a loaded word. The accuracy of the temperatures the thermocouple mentions. The thermocouple can read. It only depends on time and the rate of change of temperature. Rate of adjustment to temperature. Introducing or like calibrating the thermocouple at the same time would only add extraneous complexity to our procedure and is not important for and does not Okay, I'm moving this to the discussion. That's going to the discussion, and the other thing is going into memo hell, which is my affectionate name for the place where all of our paragraphs go to die when they are done living around here. Okay. I don't think I have it open. All right, let's do. Okay, I don't want to do this too much more. I kind of want to, let's see, I'm probably gonna wrap up soon-ish. Gotta turn on a light real quick after this. Memo limbo. Wait, let me this. I'm really, really, really happy I found this image because this is exactly what I wanted. Like, exactly what I wanted. Let's close that. Open this. Look at this. This clip art of death. It's so good. This is the mascot for my memo lib, because I like when you're writing like any big thing, like if you're writing like a PhD or something, if you're writing a book, like it's always good to have like a place where you just copy and paste stuff that you're completely cutting just in case you need something and like need to go back and reference it. It also eliminates my teammates getting mad at me for deleting things that don't need to be there because they go, why is this not here? And I go, oh, just check the memo limbo document, and then if it's something that needs to be added, and again I didn't talk about it, then you can add it back in. You should always do that for documents. Anyway, I would like to let's do a little bit of chem before. This is no longer just a math stream. It's no longer just a static stream. But, you know. Let me close this and this. Okay, what can we do? We do some voltaic cell stuff. I mean, that's like kind of This is kind of mathy. Here, this is like a long question. Let's do this one. For an electrolytic cell. This is not exactly what I need to... Whoops, my mouse died. This is not exactly what I need to practice, but... Go with this. Okay. An industrial electrolytic process. Following equations. How long would it take to produce enough... How long would it take, okay, to produce enough aluminum to make a case of 24 cans if each can used 5 grams of aluminum, a current of that was employed, and the current efficiency was that. Oh boy. Well. Okay. Okay. God, okay. There's a lot of steps. So I think we start by doing this. So we know it's going to be 5 times 10 to the 4th amps. Right, and we know that's going to be at 0.911. That's going to equal... That's like how many electrons, I guess, we get. Or how many electrons, like, go to the equation. Okay, so if that's 4.5... Wait, this, let me just say, divided by 10 to the... Yeah, 4.555 times 10 to the... Those are actual current. So current is amps. Amps is like a certain unit. 10 to the 4th. And amps are a certain amount of volts per second, which is how we're going to get to. But we want to, we'll actually probably want to not take this approach at the crux of our solution. Ooh, okay. Sorry, I need to go to modules. Then I need to go to week 9, but it's not week 9, it's week 8. Because I don't know why. Anyway. An amp is 1 coulomb, so this is coulombs per second. So we need to make 5 grams of aluminum. How many? Okay, well, we need 24 cans times 1 can is 5 GAL. Right, so that's going to be, and we want to go from grams to mole because we need moles always, almost. So we go periodic table. Because I don't know the molar mass of aluminum off the top of my head. What am I? Chemist? 26.9. 1 mole, okay. And we know that from our cathode reduction, 1 gram of aluminum is going to be, or 1 mole of aluminum needs 3 electrons. So 1 mole Al is 3 E minus. Now, how many electrons are in a coulomb? How many? Okay, wait, I don't need to look that up. How many electrons are in a coulomb? It should be on here. Or this is 3 mole E, sorry. Mole E. So 1 mole of E minus is a lot of coulombs. 96485 coulombs. And then we go to what is this? We have 4.555 times 10 to the 4th current coulombs per second. And that should give us in seconds. And then, yeah, it's just a unit conversion problem. Okay, so 24 times 5 times 3 times 9, 6. This divided by... Oh, this is going to be... Oh, no, it's not going to be that. Divided by Not gonna be as big as I thought. 28 seconds. Well, I mean, I don't know if it's right. It might not be right. 28, but I got 28.26 seconds. That seems very small, but it is a very large current. Well, let's see. How much is like our normal current in an electrical socket? 20 amps. Okay, this is a very large current. So let's see, 26 seconds? In seconds. It does say in seconds. So 28.26. Okay. I just need to reload the page. Please be right. Please be right. Yes! Yes! We got it, Chad. We got it, Chad. Big win. Okay. Let's see. I love this question. You want to electroplate tin onto a spoon. Why? Why would you want to do that, is the thing. Why would you want to do that? Let's see, this one, I don't really think we need to do that. Maybe we could do that. Just another little voltaic question. I like voltaic cells, they're pretty cool. Let's see. We build a voltaic cell using 2 half cells. Cu and Cr, so copper and chromium. Chromium? Right. My chemist. Yeah, it might be a little awkward if I'm Cr. Chromium, good. Okay. Not just a web browser. Alright, the concentration of both of these ions is 1 molarity, so that means we're getting our standard table, or whatever. Our fun little guy. So our standard is gonna be, let's see, we just gotta pick out our C, so Cu is gonna be 0.25. Well, Cu plus, is it CO2 plus? CO2 plus. CO2 plus is gonna be 0.3 volts. And Cr3 plus, somewhere in here, -4. So this one is going to be reduced, which is at the reduction is at the cathode. So it's going to be oxidized at the anode. Anox and a red cat. That's how I remember it. There's an ox. And a cat. And they're friends. Teehee. Together with the power of oxes and cats, we can make voltage. Wow, yes. Generate electricity. English is strange. Okay, so it's E cathode minus E anode, I believe. Yes, so E, so 0.34 plus 0.67. It's gonna be what? 1.808. That is our E cell. And then it's asking for the voltage. That's the voltage. I don't know what else there is to say. I'm pretty sure that's just the voltage. I thought we were gonna have to find G standard or something. Yeah, that was it. Okay. Yeah, so it's like this is how I remember it. It's like, if you have, this is the anion, it gives E minus, it gets the anions, so it shits out positives, because it gets it from the salt bridge. That's what it gets it from. And then the cathode gets the positives, and it gets the E minus, and so it slurps up the positives from the salt bridge. That's my favorite picture. This makes me very happy. I don't know why. It just like feels correct. I mean, it is correct. I just like it when things are like, this is a logical model that I can apply, and it's good. Okay, let me see. I still can't believe our uncertainty is so high on this. It's so bad. Fuck, man. Oh god. I wish I could write them so badly. I don't know. I mean, I wouldn't be that much better than us working as a group, but at least it would, like, freak me out less, because there wouldn't be all this, like... When you, like, work in a group, and it's like... Does gender fluid imply the existence of a gender solid? Absolutely. My question is, does gender fluid imply the existence of a gender vapor pressure? And is your gender fluid volatile or non-volatile? Is my question. Oh, now we're cooking. I think I have a very volatile... No, I'm not gonna be honest. I do not have a gender vapor pressure. I wish I had a gender vapor pressure. Vapor pressure is actually very cool. Vapor pressure was the thing... Okay. I'm kind of mad because, like... So, in, like, the second half of this, like, thermochem stuff, right? It's like... Delta G kind of just has its hands everywhere. Right? He's kind of there, and you can try and ignore him. But, like, he's still there. And I feel like one of the... Because we were talking about, like, colligative properties a lot, right? Which are properties that depend on... They depend on, like, the fact that there's other stuff with your solvent. Not, like, what the other stuff is, but it's always going to happen. Stuff that happens to your solvent, right? When it turns into a solution. And, you know, we're talking about, like, vapor pressure, we're talking about colligative properties, and I feel like that's such a useful thing to define the second half of the course. But he's like, guys, we're not going to have any vapor pressure stuff on the midterm. And I'm like, what? Because, like, colligative properties are, like, that's, like, conceptual heaven, right? Saying, like, if you have a higher, right, there's graphs, you know, like, the thing that's, like, oh, this, and, like, your boiling point is elevated, and, like, your freezing point is depressed, and, like, you know, like, there's so much stuff you can do there. And he's like, that's not going to be on the midterm. And I was like, what the heck? And I don't know if he just means, like, the calculations won't be on the midterm and the vapor pressure stuff will. But I just enjoy the idea of thinking about vapor pressure and that kind of stuff. It's pretty cool. But I mean, you know, there's also other conceptual stuff, right? In, like, the second half of a thermochem type beat, because, like, you'll have your cells. Your cell stuff is pretty conceptual. Like, knowing this, you know, that's pretty conceptual. What else? Anything like Le Chatelier principle is pretty conceptual. But I mean, like, then again, that's delta G, right? That's Q's and K's and delta G's. Spontaneity, solubility, kind of all delta G's. My solubility is, like, okay. I'm like okay at it, but, like, it's... I'm not gonna lie, it's like kind of harder. Because, like, we didn't really talk about it that much, and the thing about solubility is, like, there's a lot more going on. Like, it's not even that... It's not even that, like, I couldn't understand it, but it's like... Ugh, it's hard. What is this? Let's see, wait. Oh shit. Wait, actually. Whoa, wait. I should apply to this thing that I just found. I've been trying to, so like, one thing that I've been going insane over is like, so I was doing registration stuff, gone for a little bit. I was getting classes, right? And one of my things to ask my advisor was, I was like, hey, so I want to do product design stuff. Not product design as a UI, like product design is like design engineer stuff, or like draftsman stuff. Like, they don't really call them that anymore, but that kind of stuff where it's like, I'm not trying to design systems, I'm trying to design like things, right? And I was like, hey, so is there anybody who I can talk to about like getting into contact with this kind of stuff? Like, because a lot of the companies that come to our career fairs are like, you know, General Motors or Boeing, or, you know, places like Raytheon, right? Like defense contractors or systems people, or obviously lots of HVAC people too. And it's not that I'm totally devoid of wanting to do those things, but it's like I want to do product stuff. So I was like, hey, you know, what's up? Where can I find this stuff? And she was like, I don't know anybody here that does that. And I was like, what? Because this school I go to is a pretty good school, right? It's very like, in America, like it's on the list of like top 5 engineering schools or whatever. And I was like, what do you mean? Like, this is like a big part of mechanical engineering. And she's like, well, you know, the other sector, it's like that stuff is super, it's always going to be around. I'm like, yeah, but like design. And so I've just kind of been like floating in the space of like, should I change like majors to a more design focused major? But like, we don't even have like a design focused, like we don't have a design focused engineering concentration even, like, so I don't know, it's a weird space. But I've been looking for like internships and stuff in like design, because I don't really care that much about what I'm taking, because the classes I would take would probably be really similar, except for just more like abstract or more like, you know, problem solving based classes instead of just like system analysis kind of things, which is a lot of upper div classes. But yeah, it's a weird space. It's like, I just want to make like ovens, or like, I don't know, like somebody has to design an oven. There's an engineer who has to design an oven. There's an engineer who has to design like, it's looking at like doors, right? Or like somebody's got to design doors. Somebody's got to design like lamps, like light posts and stuff. But it's like, is that an engineer? Is that not an, you know? I don't know. They're out there. They're opportunity. There's a guitar fabrication internship, but I can't. They don't want people who don't play guitar. And I'm like, dude, I would love to do a guitar fabrication internship, and they've been looking for somebody for like a year. It's because nobody plays guitar here. They keep emailing us. They're like, please, we need a design. We need a cool design engineer. And it's like, I don't play guitar, but I would love that. That's so cool. Anyway, let's see. Well, okay, I've been going for about 2 hours. I should probably wrap up soon, because I have to do more chem stuff. Midterm tomorrow. Equilibrium constant. I don't know. These are pretty easy to do. It's just concentrations. Wait, I did this one. No, I didn't do that one. Drawing molecules is my worst nightmare. I'm not gonna lie. That and like solubility stuff. But it's because I should probably look into solubility more. Oh, I didn't do this one. Oh, this is new. Ooh. What is the relationship between E and G standard? What signs on each predict a product-favored reaction? Okay, product-favored reaction is when your delta G is negative when you're making products. When delta G is less than 0, They have opposite signs because E is... Okay, that's easy. That's not even a question. What is the voltage of a cell at equilibrium? Well, if it's at equilibrium, I think it's 0 volts. Yes. Because your reaction's not happening anymore. So you can't be putting electrons in there. Suppose that we make... Okay, you can't see any of these things. That's the wrong thing. Here we go. Suppose we make this electrochemical cell. Alright. Which metal will be the cathode? Y. Metal will be the anode. X. How do electrons flow? From Y to X. Oh my god, from the salt fridge. No. Sorry, from X to Y. Always X to Y. Which one is the positive electrode? Okay, positive is X. What? Oh. Okay. The one that's getting more negative. I mean, like, this one is getting more positive, is what I'm thinking. Because it's, like, going away. But yeah, this is the anode, right? So, that's the negative one. Wait, what? What is this? Oh, iron with chlorine, I see. I don't need that. Okay. Oh. You know, it writes each spontaneous, write the spontaneous electrochemical cell from above in standard cell notation. Well, it's going to be Cu, and it's going to be Cu. But is it this one or this one? What? Why is it PT? Copper with silver? Yeah, I don't know what's up with platinum. Unless we put platinum electrodes in there, and they're inert. I don't think we did that. I don't know what the fuck these are. Okay. This one, they shouldn't be matching, and also that shouldn't happen. So whichever one is more... more electronegative... Not more... Jesus Christ. Whichever one has a higher E cell. Let me close this for 1 second, so I can switch over to this. Okay, we're fine. I cancel. There we go. Our E cell table. Here we go. We're looking for AG and CU. So AG or CU, which one is first? AG. Except if we have, let's see. Is there another AG? More accurately, is that the right AG? Yeah. Okay, that one is the anode. Okay, the anode gets oxidized, so that's the... Yes! There we go, baby! There we go! Cathode gets reduced. Shit that's higher on the table gets reduced. Okay, this is good stuff to do. Although I feel like this is pretty straightforward. Oh god, which one favors products at equilibrium? Wait, what? Oh. That's... interesting. Oh, it'll just say, like, what? Yeah, that's fine. Oh, wait, this one, let's see. Oh my god! An important reaction in cellular respiration follows. Identify the oxidizer and the reducer if this is a redox reaction. Alright, so... we're going from NAD plus to NADH. So, let's see. I don't even see a different chemical structure on there. Oh, I see. There, it's right there. You can't see it. There's a little plus here. So this one is gaining. This one is gaining an electron, which means it's being reduced. So NAD is being reduced. Which means that NAD plus is the oxidizer. It's being reduced. Okay, and lactate is going to be something. Because, like, your things at the beginning are your things that you're doing with. So lactate is going to pyruvate. It is gaining electrons. It is getting oxidized, so it is the reducer. Is we right? Yes! Yes! Correct. Frameworks. Okay, anyway. That's all I got. That's all I got for today. Here. Like, we can look at... Oh, wait. What did I just do? I turned off my quick capture. There we go. We can look at this awesome, fun picture of a cat and a cow holding hands. I'm gonna be streaming on the weekend, probably. We're gonna hanging out. I know I made an Among Us last time I had a break. I don't have an Among Us to make. Unfortunately, the project that I have to make is much more boring than an Among Us. It is a table, and that's the whole project. So we won't be working on that, especially since I have to write a preliminary design report on what is it's a table. We did a decision matrix, right, based off of like criteria for this table. Our design's tied. That's how much the table like doesn't matter. We had the exact same value for both of them, which is insane because we just like we didn't actually put numbers like in. We just like we didn't actually put scores into this decision matrix and like normalize them like we should have done because we haven't built the prototypes. It's a thought experiment, but like we got the exact same number for both of them. It's crazy. That's like statistically implausible. It's the word. All right. I will be back on Saturday or Sunday or both. And then during the week. That'll be fun. I kind of want to maybe we'll do some rigging because I kind of want to work on a lion dance model just for fun and to like learn some new Live 2D stuff or for some other reason. But no, that's not. It won't be an actual model that I use. Anyway, I will see you guys. I'll see you guys then. I hope everybody has a great week. If you have tests, like me, good luck. If you don't, awesome. Enjoy not having tests. And I will see y'all next time. Bye.